All right, we're recorded, I think. Throw your name on here. It is currently second hour. Okay, today we are factoring quadratics. Specifically, we are factoring quadratic trinomials. Somebody either access your brain or your 5.1 notes. What degree does a quadratic have? That's a quartic. Roman? That's cubic. 2. A quadratic has a degree of 2. This one's easier. Trinomial, how many terms does it have? 3. Okay. We are going to be taking polynomials that look like this. X squared plus bx plus c, where b and c are numbers. We are going to be factoring them to look like this, like a binomial times a binomial, like what we had in 5.4. So we're going to be factoring to look like that. So this is what our problems will look like to start. This is what they will look like to end. Today, there is no number in front of x squared. Technically, there's an imaginary 1 there. When we get to 5.9, we'll learn how to factor when there is a number in front of x squared. Today, we are just doing quadratic trinomials with a leading coefficient. That's what that number is called, the front coefficient. A leading coefficient of 1. That's why I wrote LC of 1 right there. Okay. As we are doing this, it's kind of like a puzzle. The two numbers that you choose, they can be positive or negative, but they always have to follow these two rules. And we will show you after our first couple of examples why they have to follow these two rules. Your two numbers, I'm trying to decide the order I want to put this in, have to multiply to equal the last number. And then that would be C if you're using this ABC up here. So multiply to equal your last number. And they have to add together to equal the middle number. So for us today, that is B. So they have to multiply to equal the last and add to equal the middle. So that's why we just stood at the boards and played the game of the puzzle of find two numbers that multiply to equal this and add to equal this. Because that's the thinking part of today, is finding two numbers that multiply to equal the last number and add to equal the middle number. And then we'll write them a certain way, and that will be our factored version. Any questions right now? Okay, moving down to my first two examples then. First one I've got is x squared plus 5x plus 6. I like to make a little note to myself until I get real good at this of what I am trying to find. I am trying to find two numbers that multiply to equal 6. So I'm just going to write mult 6 right there. So I'm not writing the whole word multiply. Then over here, just so I have somewhere to put a note of it, they need to add together to be 5. So I'm looking for two numbers that multiply to 6 and add to 5. On your assignment, you can write as many or as few factors as you need to. On the notes, I'm going to go ahead and write all of the factors so we can see our options, because some of us might need or want to do that. So my factors of 6 are 1 and 6, 2 and 3. And then I don't need to try 3 because it's already on the other side of the list. What pair of those add together to be 5? So right now I'm trying to add to be positive and multiply to be positive, so I don't need to worry about any negatives yet. So we don't want to make anything negative because we're not trying to multiply to be a negative. So multiply to be positive 6, add to be positive 5, 2 and 3. So I'm going to circle those. Here is how you write your answer. Your first set of parentheses needs to say x plus 2. Your second set of parentheses that's getting multiplied by that needs to say x plus 3. Those could be flip-flopped. You could do x plus 3 times x plus 2, and that would be fine. And that's your answer. Okay, we're going to do one more, and then I want to show you guys how you can check these using the multiplication, and then we'll start cruising through them a little bit faster on the back. We've got x squared plus 10x plus 21. What am I trying to multiply to be? 21. That's my last number. I'm trying to multiply to be 21. What am I trying to add to be? 10. Awesome. Okay, my factors of 1 and 21 are, my factors of 21 are 1 and 21. Does 2 go into 21? Does 3 go into 21? Okay, what goes with 3? 7. Does 4 go into 21? So if 2 doesn't go in, 4 and 6 aren't going to go in. Does 5 go into 21? No. Okay. Which we can say here and we can think, well, like 4 goes into 20, so it's obviously not going to go into 21. Okay. So which ones of these add together to be 10? 3 and 7. Awesome. Okay, I've got x plus 3 and x plus 7. And that is my answer in factored form. All right, any questions right now? Okay, we are going to check 2 problems using multiplication, just these 2 on the front. We're not going to do it for the examples on the back, and I'm not going to make you do it on your assignment. But I want to show you guys that this is the opposite of what we did in 5.4. And you won't, I need you to see it. So this first one, when we check it, let's use our little table, because I know some of us liked using that. So if I were to do a little 2 by 2 table, I'm going to put x and 2 on the left. I'm going to put x and 3 on the top. And then I'm going to go ahead and make both of my x's 1x to the first, 1x to the first. Okay, so 1x to the first times 1x to the first. 1 times 1 is 1. And then I add my exponents. 1 plus 1 is 2. So I get 1x squared. Then my top right box, 1x times 3 is 3x to the first. Two times 1x is 2x to the first. And 2 times 3 is 6. Okay. From there, we are now going to combine like terms. So my x squared will stay by itself. What can I combine together? Okay, these 2 guys, 3x to the first and 2x to the first. Those combine together to be 5x to the first. And then I still have my plus 6. Do you guys see that that is the same as our original problem? Okay. When we multiplied this out, when we combined like terms, we added 2 and 3 to be that 5. When we multiplied 2 and 3 to create that 6. So that happens every time. Okay. We're going to check one more using multiplication. This one I'm going to distribute, though, because I know some of us like that method. So if I was going to distribute, I would do x times x, which is x squared. I would do x times 7, which is 7x. I would do 3 times x, which is 3x. And I would do 3 times 7, which is 21. So if you chose to not do the table and just distribute, that's what you would get. Then I would combine together my 7x and my 3x, and that would make my 10x. So I still have x squared, 7 plus 3 is 10x, and I still have my 21. Okay. So on these first couple of examples, I wanted to show you why we write them like this and how we can get back to what we originally had. Any questions right now? Okay. Stop doing that with the glue stick. My number 2 pet peeve. Okay. Then let's flip this over. On the back, we have 4 more examples, and then we have this table that we are going to fill out that's going to help us remember whether we use positive or negative numbers or one of each, and if we're using one of each, what type. Okay? So we're going to do an example, fill out a row of the table, do an example, fill out the row of the table. Let's just cruise through this, and then we'll still have about 30 minutes at least to work on our assignment. Okay, first problem we've got, x squared plus 17x plus 16. What are we trying to multiply to be? Okay, somebody other than Atlas, what are we trying to add to be? 17, awesome. Okay, numbers that multiply together to be 16. What multiplies together to be 16? Okay, 4 and 4. What else? 1 and 16. And somebody just said 8 and 2. I'm going to put it as 2 and 8. Okay, so you guys got all of them, but I went ahead and re-put them in order there. Okay, which ones of these add together to be 17? 1 and 16, okay? It's the only way to get to something bigger. So my answer here is going to be x plus 1 times x plus 16. And again, you could have that flip-flopped. You could have x plus 16 and x plus 1. All right, moving down to my cool table. This first problem, the middle number that we were trying to add to was positive. The last number that we were trying to multiply to was positive. In order to add to be a positive number and multiply to be a positive number, what types of numbers did we choose to use? Positive. So you are going to pick 2 numbers that are both positive. Okay? So that's your first row of the table. Is that if you're trying to add to be positive and multiply to be positive, everything's going to be positive. It's just positives all around. Okay, questions? Okay, this next one is a little tricky, but not once you figure it out. Okay, take a second and think. Don't shout it out yet. Take a second and think, what are we trying to multiply to? Shh, don't shout it out yet. Okay, give everyone a second to think. And then now shout it out in 3, 2, 1. Negative 20. Okay, trying to give more people opportunities to think. This one's tricky here. Raise your hand if you think you know what we're trying to add to. Peggy, what do you think? What? Negative 1. Good job. So there's an imaginary 1 here. So we need to know that that 1 is there. And we need to know we're trying to add to negative 1. Every once in a while, I'll have somebody be like, I'm trying to add to x, but there's no x's. And then they get like real confused. All right. Factors of 20 are 1 and 2 and 3 and 3 and no, 4 and 5. Okay, any questions on those being our factors? Okay, in order to multiply to be a negative, we know that one of our numbers is going to have to be negative. Since we are trying to add to be negative, I like to look at a number line and like look at 0. If I want to end up on the negative side of that with 2 numbers, my bigger one needs to be negative. So since I know I need to add to be negative, I'm going to go, and if I do my factors like this, I can make all of my bigger ones negative. And then from there, I can pick which set adds to be -1. And in this case, 4 and -5 add to be -1. So my factors are x plus 4 and x minus 5. Okay, any questions on that? Okay, moving on then. Well, we need to fill out our table. So this one, we were trying to add together to be a negative number, and we were trying to multiply together to be a negative number. We know anytime we're trying to multiply to be negative, we're going to need one positive and one negative. So that's the first thing I'm going to put down. But then I'm going to leave space to add in another note. If I need to add to be negative, I want my bigger one to be negative. So one positive, one negative, and you're going to want your bigger one to be negative. Okay, hold on to your pencil, Damien. Stop dropping it. Okay. Two more examples. We've got x squared minus 8x plus 12. I'm trying to multiply to my last number, which is 12. I'm trying to add to my middle number, which is -8. Okay, I'll give you the first one, you give me the second one. Now, factors of 12 are 1 and, 2 and, 3 and then I'm done because 4 is on the other side, so I don't need to do 4 and 3. Okay. Think back to when we were at the boards. Think back to when we were talking about what we did at the boards. Raise your hand if you can tell me how to multiply to be a positive number, but then add to be negative still. Michaela. Both negative. So we're making everybody negative here. Okay, so everybody's negative. Then you pick the ones that add to -8. So since everybody's negative, you can pick the ones that would add to be +8, but then they're both negative, so then they add to be -8. So I've got -2 and -6, because 2 plus 6 is 8. -2 plus -6 is -8. When I write my answer, I'm going to write x minus 2 and x minus 6. I did it on the last one, but I didn't mention it out loud. Do not write x plus -2 and x plus -6. That's just unnecessary. It's going to mess things up in the future. Okay, let's fill out our table. In our table, our next row, we just added to a negative, but still multiplied to be positive. And how we did that was by using two numbers that were both negative. Okay. Last one, x squared plus 5x minus 24. We are trying to multiply to -24. Because that's my last number. And we are trying to add to be 5. Okay. Numbers that multiply to -24 are Well, numbers that multiply to 24. I always do it with the positive and then worry about if I need any negatives. 1 and, 2 and, 3 and. You really want 6 to be there. 3 and 8. Okay, now's your time to shine. 4 and 6.
Why is my brain not working?
I don't know. Now's the time you get to shout 6. Okay, and then 5 doesn't work. We know 5 goes into 25, so like we know it's not going to go into 24. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. You're going to want to start drilling these factor pairs of these common numbers to your brain. Okay, which ones of the... Oh, now we need to add to be positive. If we know we want to add to be positive, we want our big guys to be positive. We want our little guys to be negative. So make 1, 2, 3, and 4 negative. And so that's why I list it like that, because then all my smaller ones are on one side and all my bigger ones are on the other side. Hey, which ones of these add together to be 5?
3 and 8. -3
and -8. So you're going to write your answer as x minus 3 and x plus 8. Okay. Again, you can flip-flop those, but you have to flip-flop the sign and the number. So it would be x plus 8 and x minus 3. So Linnea, I only wrote it one direction on the key. It doesn't have to be in the same order, but the negative and the positive have to be with the right numbers, okay? All right, questions. Last row of our table. We just added to be positive, but multiplied to be negative. Anytime we need to multiply to be negative, we know it's going to be one positive and one negative. Then in parentheses, the type of number I used for that was I picked two numbers and I made the bigger one positive because I want the more powerful one to make things end up being positive. Okay. Questions, concerns, emotions, thoughts, anything at all for the good of the cause. Okay. I'm going to stop this delightful video.